In this problem, we want to balance the redox reaction in an acidic solution. Recall in a redox reaction, there are electrons that are being transferred from one species to another. We can balance the redox reaction by using the half reaction method. In the half reaction method, what we'll do is we'll tie up these species that are related, for example, the iron 2+ and the iron 3+, and then we have another species here, the permanganate, Mn O4-, and that's related to our manganese 2+, of course. And so in the half reaction method, what we'll do is we'll write these half reactions. So Fe2+, aqueous. I'll give myself some space because we'll have to add some species in here. And iron 3+. And in the second half reaction, we have the permanganate. Again, I'll leave myself some space because I might have to add some things in here. And the product is manganese 2+. So we'll follow the rules of the balancing half reaction method. So we'll go one at a time here. So the first rule, of course, is to balance the elements other than oxygen and hydrogen. In the first half reaction, of course, there's only 1 mole of iron and 1 mole of iron. So that's already balanced. And of course, there are no oxygens or hydrogens to balance, so there's nothing to do on the first one in terms of balancing atoms. But in the half reaction method, we need to balance charges as well. You notice there's a difference in charges. This iron is a 2+ oxidation state, and this iron is a 3+ oxidation state. The way we balance charges is by adding electrons. Electrons are negatively charged. So we'll go to the higher charge, +3, and we'll add electrons so that the charges balance on each side. So we want this 3+ to come down to a 2+, and we'll do that by adding 1 electron. Okay, let's move to the second reaction. In the second half reaction, we have permanganate yielding manganese 2+. So we'll balance the manganese, 1 mole of manganese here. On the product side, there's 1 mole of manganese, so that's already balanced. But we'll notice something we didn't see earlier. There are 4 moles of oxygen in the permanganate. So we balance oxygen using water. The phase for water is liquid. Now, water has 1 mole of oxygen. We want it to balance with 4 moles of oxygen, so we'll add a coefficient of 4. And so this means there's 4 moles, or 4 times the water. Each water has 1 oxygen, so that gives us our 4 oxygens. By adding water, we've also added hydrogen. So now we need to balance hydrogen using H+. So 4 times 2 is 8. So on the reactant side, we'll add 8 H+ aqueous. So now all the atoms are balanced. What remains is to balance the charges. One of the things you'll notice here that the charges are not balanced. 1 mole of permanganate is a negative charge, and 8 moles of H plus gives us 8 positive charges. So just doing a little count here, there's a plus 7 on the reactant side. On the product side, 4 moles of water are neutral, and we have 1 mole of the manganese 2 plus. So of course this is a plus 2. If we want the charges to balance, we need to add electrons to the higher charge and bring that higher charge down to a plus 2 to get them to balance. So of course here we'll add 5 mole of electron. Plus 7 minus 5 negative charges, of course, gives us our plus 2. So now atoms are balanced, charges are balanced in both half reactions. And before we move on, let's go ahead and identify our species. Let's identify what's being reduced and what's being oxidized. Let's identify the reducing agent and the oxidizing agent. Whenever we see electrons on the product side, we can think of electrons coming out of our starting material. That means that the Fe2 plus is losing 1 electron. So the Fe2 plus is being oxidized. The Fe2 plus oxidized means it's losing electrons, and that means it's reducing something else. And so the species oxidized or losing electrons is also called a reducing agent. For the second half reaction, you can think of electrons on the reactant side as electrons going into a species. So right here, the manganese negative, permanganate is gaining the 5 electrons, and so that means that this species is reduced. And by gaining electrons from the iron, iron's being oxidized, that means permanganate is the oxidizing agent. So we've identified our species. We know what's being oxidized and what's being reduced. Okay, let's get back to our balancing. We want to add these half reactions to give us the final balanced equation. But before we do that, there's one more thing we have to accomplish, and that is balancing the electrons transferred. Here, 1 mole of permanganate is losing 5 moles of electrons, and 1 mole of iron, 2 plus, is gaining 1 mole of electrons. So the electrons don't balance. So what we'll have to do is multiply the top equation by 5. So I'll put here in brackets times 5. And below the half reactions, I'll go ahead and rewrite this equation. 5 mole of Fe2 plus aqueous, 5 mole of Fe3 plus aqueous, and 5 mole of electron. And so right here you'll see that we have a balanced redox reaction. 5 moles of electrons are lost while 5 moles of electrons are gained. So we'll cancel out what appears on both sides. And that's it. Let's go ahead and put these together. I'll start with this first reaction. 5 Fe2 plus plus the permanganate plus 8 moles of H plus. The electrons have canceled, so we'll ignore that. And then on the product side, 5 mole of Fe3 plus, 1 mole of the manganese, 2 plus, and finally 4 mole of water. If you look closely, you can confirm that the atoms are balanced. You can also confirm that the charges are balanced. So right here, we have 5 times 2, that's a 10 positive, plus 8 more is 18, and then minus 1 gives us a plus 17 charge. And then on the product side, we've got 5 times 3, that's a plus 15, plus 2 more, that's a plus 17. Water, of course, is neutral. So you notice that in a redox reaction, we balance not only the atoms, but also the electrons transferred. In the end, we should have the same charges and atoms on both sides of the equation.